So formal deductive logic, there are two types of mistakes in formal logic commonly made by evolutionists. One is affirming the consequent, and the second is denying the antecedent, as Lisle says. That may sound like gibberish at the moment, but you'll soon see that you already know exactly what we're talking about here, though perhaps not by those fancier technical terms. First, then, we must lay out the basics of formal deductive logic. You'll have encountered this before, perhaps in high school or college, or mentioned in passing in popular culture. Jason Lisle writes, "Formal logic is that which can be represented with symbols such as if P then Q, where P and Q represent any generic propositions. Formal logic is deductive in nature, which means the conclusion definitely follows from the premises, if the argument is valid." So a valid deductive argument goes, as you see on the slide here, 1, the first premise, if P is true, then Q is true. 2, a secondary premise, P is true. And then 3, the conclusion, therefore Q is true. So if P is true, then Q is true. P is true, therefore Q is true. So an example would be that Lisle gives us the first premise then, if it is snowing, P, then it must be cold outside, Q. And then second premise, it is snowing, so P is affirmed, and so the conclusion is therefore it is cold outside, Q. Also note here that the first statement in the hypothetical if-then statement, that first premise, the if part, or P, is called the antecedent, which just means what comes before. So if such and such, that's what comes before, then the second part, Q, is called the consequent, what follows, the consequence of what came before. So that's some basic terminology and basic formal deductive logic there. Valid logic. So the argument before you, first premise, if it is snowing, P, then it must be cold outside, Q. Second premise, it is snowing, that's affirming the antecedent, affirming what goes before, the if statement, and then the conclusion, therefore it is cold outside, Q. So this is valid because it affirms the antecedent. That is, the second premise, it's snowing, affirms the first, P, the antecedent, affirming what comes before. That's a valid argument. Recall that the two types of errors we're watching for here are the mistakes of affirming the consequent, affirming what follows, and the mistake of denying the antecedent, denying what comes before. These two errors are errors because they contradict either the if or then of the first premise. There's a second type of correct logic, sound logic, valid reasoning, which is denying the consequent. So the premise, if it's snowing P, then it must be cold outside, Q. Then the second premise, it is not cold outside, not Q, which is denying what follows, denying the consequent. And the conclusion, therefore, it's not snowing, not P. So this is valid. Because this argument denies the consequent, it's also a valid argument. You can see how both of these forms of reasoning agree with one another. They're consistent. Both affirming the antecedent and denying the consequent are valid. However, as we've been saying, there are two ways to mess up formal logic and so make an invalid deduction. So invalid logic, the first example is affirming the consequent. So this is invalid. So this one goes, as you see, the first premise, if it is snowing P, then it must be cold outside, Q. And then the second premise, it is cold outside. So affirming what follows, Q. And then the conclusion, therefore it must be snowing, P. So this argument's fallacious. It's an error because it's invalid because although the first premise is true as before, the second premise is false. That is, while the truth of P guarantees the truth of Q, it's not true the other way around. Just because Q is true, that it's cold outside in this case, that does not guarantee that it's snowing, P. So this is the mistake of affirming the consequent, affirming what follows, thinking that the then part can guarantee the if part, whereas we all know, when we think about it, that it's always if then, not then if. So an example from evolution which engages in this mistaken logic of affirming the antecedent is, what have I written here? Affirming the consequent. I don't know why I wrote that. So an example of this mistake from evolution is one, the premise. If evolution were true, that's P, the if statement, the antecedent, then we would expect that organisms would share some similarity in their DNA, Q, the consequent, the then part of the statement. Second premise, organisms do share some similarity in their DNA, so that's affirming the consequent, which is the mistake here, Q. Then 3, the conclusion, therefore evolution is true, P. So this is a logical error that evolution makes, that we can demonstrate here when we write it out as formal logic. So it's a great tool for identifying logical errors. And this is one of the basic tenets of evolution. This apparent similarity, supposedly evidence for evolution, whereas in fact you can see it's a logical fallacy. So it's one of the big errors that we saw Rhett and Link fall into, and we use them as an example of Christians who were deceived and deceived themselves. They had a number of errors they made, but this is one of them. In that video we showed I didn't show the video, but I did discuss it and encourage you to go look at it. You can see that in a former talk where they turned their back on God's word. What happened was Rhett looked at the similarity between ape and human DNA and concluded that evolution's true. But as Lisle points out, there could be many reasons why organisms have similarities in their DNA. For example, they all have the same creator, right? So evolutionists commit the error of affirming the consequent when they argue in this way. So we can see the value of learning formal logic in order to be able to assess bad argumentation like evolution uses all the time to support its false claims. So unsound logic, a second type of error in thinking, is denying the antecedent, denying what comes before, denying the if statement. So to go back to the example just so we can understand, the first premise, if it's snowing P, then it must be cold outside Q. And then the second premise, it is not snowing, not P. So it's a denial of the antecedent, denial of the if statement. Conclusion, therefore it is not cold outside, not Q. So here, this is an error. While the first premise is perfectly valid, the second premise is also valid, but the conclusion drawn from the second premise is not valid. It's a mistake. So this is the fallacy of denying the antecedent, denying what comes before, because the second premise denies the antecedent, yet this does not guarantee the conclusion. Just because it's not snowing does not mean that it must not be cold outside. Right? We know it could be cold without snowing. So the argument's fallacious because it can have true premises and a false conclusion. So evolution, those who promote the myth, the lie of evolution, also engage in this kind of logical error. So an example of denying the antecedent is, the premise, as you see on the slide there, if we found dinosaur fossils and human fossils in the same rock formation, P, then this would indicate that they lived at the same time, Q. Second premise, we do not find dinosaur fossils and human fossils in the same rock formation, not P. Although I think there has been some evidence to that, but it's very uncommon if it occurs. Anyway, sticking with the argument here, assuming we do not find dinosaur fossils and human fossils in the same rock formation, 3, conclusion, therefore they did not live at the same time, not Q. That's how the argument goes from the evolutionists anyways. So this argument commits the fallacy of denying the antecedent. Denying the antecedent. Denying what goes before. Denying P. There are a number of reasons why we would not expect dinosaur fossils and human fossils together, right? For example, if they typically didn't live in the same regions before the flood, which makes a lot of sense. So here, the conclusion does not necessarily follow from the premises. So that's a logical error that evolutionists make all the time as well.